I'm Alex Brown, and I'd like to introduce you to the Composite Joist Floor System Aid. This tool will take your basic load and concrete slab information and apply it to a floor joist. It quickly and accurately gives you a 3-part composite joist designation, as well as information about the final joist design. Using this tool allows you to make informed decisions, ensuring that you get the most economical design for your building. And with that, we can jump right in. I'm here on the main page, the Design Tools page at Vulcraft.com. And this particular tool is located kind of towards the bottom of the joist section, the Composite Joist Floor System Aid. If I open that up here. So the first thing I want to point out is just right across the top here. I can input a project name, I can input my name as the engineer, an internal job number. All of this is just, it's optional, it's for your convenience if this is something that you want generated on the final printed outputs and reports. But yeah, just to kind of start at the top, and then we work our way down from there. The composite dead load section here is shown. So there's a couple of different options, and all of these just get summed up to that total composite dead load. So if, just as a convenience, if I did want the design tool to do the math for me, it will. Otherwise, I can type in kind of whatever my number is and know that it's going to get added up to that total number correctly. For the live load, we'll throw in 100 PSF, and then the design tool will reduce it if I tell it to, and that'll calculate it based on the spacing and the span of the member and adjust it accordingly. Or if it's non-reducible, I can just leave it at that. For the construction live load, there's this tooltip here that I want to point out. And if we go to the construction live load info tab here, there's this excerpt from ASCE 3714, which shows this table 4-4. And all of this is going to be the expected construction loading based on kind of what the erection method or usage is going to be. So for our case, we'll just figure 25 PSF and punch that in back on the first tab. If I add a partition live load, I could punch that in here as well. There's a tooltip referencing IBC section 1607.5, which kind of goes into what those expectations would be if they were present. And then moving over to the deck section here, all of this is going to be used to determine what the volume and the subsequent weight of the wet concrete is that the joist has to carry non-compositely before that concrete cures and it can act in a composite manner. So all of this here, we'll figure a 3.25 inch slab topping, so 6 1/4 inch slab altogether, 3,000 PSI concrete, slab weight of 145, so just normal weight stuff. And then back to the middle, this steel properties section, this is going to be about the steel and the shear stud. So we'll just go ahead and figure 50 KSI steel and 5/8 inch diameter stud. So with all that slab and design information punched in, we can come down to the span input section. There's 4 spots here for different designs if we wanted to. And the differences is going to be with the span and also the right and left spacing. So we can kind of play with the different tributary areas and the different lengths of joist and have 4 joists sort of on screen visualized at once to be able to compare between them. So if I wanted a fairly long span, let's say maybe 75 feet, first thing I get here is this red X that pops up. And unfortunately, sort of the limits of the tool, what we can accomplish within the Excel file behind it, it's capped at a 70-foot maximum span. If I have a scenario that's longer than 70 feet, that's not to say Vulcraft couldn't build it, but it's definitely worth contacting your local Vulcraft sales office and get in touch with an expert who can sort of run that scenario specifically through our proper design service. Let's just go with 50 feet for this example. And it loaded in this suggested depth. That's automatically calculated based on a span to depth ratio of 18. And you can see it's already trying to generate the composite joist designation below here, even with no spacing yet. So all of that will update as we kind of work through the different cells. If I did want to override this 34-inch depth, I certainly could. If I wanted to just shallow it up a little bit to 30, you can see it's adjusting that, and it's already starting to update the resulting self-weight of the joist and stud count and all of that. Or if I wanted to make it that much deeper, I could also do that too. So this gives kind of that manual control over what the design is, if that's something that's important to you. Or if you're just looking for the most economical, you can leave that blank and it'll run accordingly. Jumping down to the spacing information here, let's just figure these joists 8 foot on center. And then now that I've got that information, it can do the math, it can figure out how all of the loading is being applied, and I've got my full composite joist designation, a 34 CJ 1440 total load, 800 live load, and 120 non-composite dead load. With that, it's got all of the resulting attributes and properties of that joist, so the expected live load deflection, W360 is the live load, which would cause a deflection of L over 360, versus this, which is a fair amount stiffer. It's only deflecting L over 700, roughly. The self-weight of the joist, the self-weight of the bridging, the effective moment of inertia that's expected from this joist, and then also the number of studs, expected seat depth, and the required bridging. So a lot of information being generated based on these inputs, and all of this stuff, it will update dynamically on the fly as information is updated. Now, of course, this is still 8 foot on center, so it's got the same information. But if I wanted to, really compare it, I could do that. And I can get my original info in here, so I could have them side by side, and I could see, what the impacts of those changes would be. So a couple of things to point out here. For the seat depth, you can see that the slightly heavier joist actually requires a 7.5 inch deep seat, where the slightly lighter joist only requires a 5 inch deep seat. And that goes back to how the SJI calculates seat depths for composite joist. It's pretty variable based on the span, the loading, and the depth. There's no clear-cut rules the same way as a non-composite joist, like a K-series or an LH series, where it's kind of set in stone a little bit more. So with that, the tooltip here has a kind of a tip as well, referencing the flush frame connection tab above. And to flip to that real quick, it's got a little bit more information about this alternate attachment method that we offer for flush frame connection instead of a typical joist seat bearing on top of the girder. So a few advantages here that you can read about, but the biggest one is that it puts the top of the girder even with the top of the composite joist, and it's going to improve some of the vibration performance and help with some of the elevation stuff. And then focusing on the maximum ductwork section here for a little bit, another tooltip referencing the large openings tab that's above, and similar to the flush frame information, it's just kind of a supplement that has some information about our Virendel openings. So these are square openings that we can build into the joists rather than having the triangular truss panels. And all of this is quite doable. We just have to know ahead of time, and that's something beyond the scope of this tool. Certainly contact your local Vulcraft salesperson or professional to get more information about your scenario that may require this. So if I punch in a third option here, and let's go really big for the spacing. And you can see the result here. We've got an NG instead of the OK. So something is up with this particular design here. And it recommends checking the supporting calcs tab above for the cause of this. So I can come in here and get a detailed look at what's going on under the hood of this thing. So you can see all of the individual calculations that are happening, and then there's a couple of checks that happen along the way. So non-composite design's okay, the composite design is okay, but looks like with the stud quantity, now we have an issue. And you can see that right here. So locations per joist span, so there's 50 possible locations for a stud along this joist span. And this particular design, just because the spacing is wider, there's more loading that has to go through that joist, it requires 74 studs. So a scenario like this, again, contacting your Vulcraft sales contact or engineering contact is going to be the best route to get a better picture of what's going on that joist, a more realistic design than what this Excel document is able to do. And then the final tab that we haven't looked at yet is this depth weight analysis tab. So if I come in here, this gives kind of an interesting what if for finding the most economical depth. So that 34 inches that it defaulted for the 50-foot span, that's just a simple span to depth ratio that's happening. To get a little bit more kind of precise with it, it tests all of these different span to depth ratios going from 12 all the way up to 30 and gives you sort of a quick overview of how economical those options are going to be. So in this case, there might actually be some room to save weight by going deeper. So a 50-inch deep joist is the lightest option of the ones ran. Now, of course, these being floor joists, clear height is a huge concern, so maybe 50 inches isn't doable just with the rest of the building design. And yeah, this gives that visibility to really dial in, what's going to work for the building, what's your maximum allowable depth. And in this case, if you go all the way to, say, a 20-inch depth, so really shallowing it up, that's cool, but it's almost doubling the weight of the joist. So a pretty substantial penalty for shallowing that joist up. And then coming back here to the main tab, the final thing I want to point out is down here. So there's been this running total, kind of the weight of the overall system within the bay. And that ties back into each individual design and then the quantity that's happening of each one. So first thing I want to do, I've still got this one that's busted for the design. I'm going to go ahead and tweak that just so I don't have an error message anymore. But now that I've got this going, if I do have these different spacings with the different designations, I can really start dialing in how many I have of each one. And as the tool goes through, you can see it's updating that accordingly. So in this case, it was a fairly small bump from 5.3 to 5.4, but I think we'll see something quite a bit more substantial if I were to start shallowing these up to that 20-inch depth. So really going extreme with it. And you can see that weight increasing accordingly. So we're up almost to 9 PSF now with the joist and bridging dead load combined. So just a better, more comprehensive way of looking at what the weight of the system is going to be in the final design. And that's the Composite Joist Floor System Aid. It's a very powerful tool. It gives a lot of great information. And if you have a scenario that's outside the bounds of the tool, kind of what it can handle, absolutely give us a call. You can use the Contact Us page on our website to find your local salesperson. But we hope that this is something that is incorporated in your workflow every time you look to use a joist in your floor system. And with that, happy specifying.